Okay, in section 19, again, the SAGE, computer algebra system. You can click on the magenta link. I hope you've been going there at least for entertainment value and playing around with the software. It's nice software. All right. There's a bunch of stuff here. Most stuff should look pretty familiar to you. It really should look familiar to you. What I want to do is I want to just simply say, yeah, I'm getting a little better at this. I want to just scroll back over the notes and kind of look at things. And in some ways, not that I want to do the problem using Sage. I want to start to explore, some simpler things about Sage that I probably could come up with. And let's take a look. Again, I'm kind of looking over this over here. Again, just moving back over the problems. I'm gonna give this one a shot here. All right, ready? So let's go back to my Sage. So let me clear. Let me reset. Let me make n a variable, right? So n equals var. And again, remember that a lot of times people can't really remember exactly what needs to be put in. So that's why they might have to look back over their notes. There's nothing wrong with that. You look back over it. All right. So let's see. I said assume, right? Assume that n is an integer. I spelled that right? I'm doing okay. Sum. Let's see if we can type this in. It looks like the top would be 4 to the n plus 2 to the n. Oops, I did the same thing. Divided by 9 to the n. Or, again, maybe I can't remember right. For n in, I'm going to say 1 to 1. Now, let's see if that's true. You get 4 plus 2, which is 6, 6 over 9, 2/3. Looks pretty good. And then again, you should maybe take another partial sum and just to get a feel for it. That's all we're doing, getting a feel. And I get 74 over 1. And I don't know, let's do 3 then. I think you understand what I did, right? I just kind of typed in numbers. And so could you keep doing this all day long? Of course I could. If I kept going, let me do, I don't know. Let's do 10 now. A little bizarre looking number. I got to approximate that because it's really hard to read that. All right, let me try something else. Let me try 100. I think you get an idea that what we're doing is, looking at the sums, first sum 74 over 81. These are partial sums, by the way, 82 over 81. I want to see if it can, maybe if I use a letter, if it could do that. And I'm going to write this down for you. And who knows, maybe it can't, maybe it can. So I'm going to say n, this is a new thing, equals a var. And again, this is what you're going to be doing. You're going to be doing this, particularly when you get upper level courses, saying, I wonder if this works. And you don't know if it works until you try. Then you might say, oh, gee, you scratch your head, you try something different. Eventually, you might have to go back to, those forums and see if someone could help you, formulate this. You might have to read a manual somewhere. Who knows what you have to do? Maybe ask a friend, ask your teacher, whatever. All right, I'm gonna. Nah, I can't do it. Unable to simplify a float approximation. And I'm gonna try to type in something a little bit different, okay? Assume n is an integer. Who knows? Maybe this will help. Unable to simplify the float approximation. There's trouble. Can't do it. All right, can't do it. All right. So someone's going to say, could you spend more time in this to figure it out? Yeah. But I got to be honest with you. I don't think we should really be spending our time doing that at this point. What we spend our time on is learning what this is about. And what did I do over there? Well, I think you kind of remember I did some work over here, right? So I want to just look at this work and see if I can do this now, right? I did some work. I did some work. So let's do this. And I'm going to type this in now. I don't know if it's going to be able to do it. All right. So I'm going to do this first sum. The argument's 4/9, right? To n for n in, whoops, not on, 1 dot dot infinity. I don't know. Maybe you can't resolve that infinity again as being a number, a natural number. And it can't do it. All right. So again, I'm still in that same loop. Is this an easy sum to do? It really is. It's a super easy sum. All right. A super easy sum to do. I want to go to one of the pieces of software though, and I want to go back to Wolfram. All right. So let me go back to Wolfram Alpha. And this is what I'm talking about. You might say to yourself, well, I'm just going to keep hacking it until I get it. I got to be honest with you though. I like doing that, but a lot of people, they don't. They want to get the simplest way possible. The more tools you have at your disposal, the better it is for you. Because if that screwdriver doesn't work, maybe the other screwdriver will work. Have more tools. Let's try this. Sum for, ready for this? N plus 2 to the n divided by 9 to the n. Yeah, if I make a mistake, it'll let me know that. For n, well, let's see, n 1. I'm just going to say 1 to 1,000, 1 to a million, 1 to infinity. Well, remember I did it approximately. Remember that? It says it converges. They got an approximate number over there. But they're not writing the exact answer down. I'm going to say that you can get the exact answer to this. We know it converges, by the way. But, oh, no, I'm sorry. They did put the exact answer down, 38 over 35. I'm sorry. I just didn't see that. But do you remember when we were doing partial sums? We were getting this number. Let me go back to Sage. I'll just scroll back up and show you that. That's a lot of big, long error messages there, right? More error messages. Remember that number we were getting? 1.085. It's right here. There were the partial sums. Okay. Again, it's important you start playing around with software. It's important you have more than one choice. When you transfer NJIT, though, my understanding of NJIT, not experience, by the way, understanding, is that NJIT forces their students to use MATLAB. You should realize MATLAB is a good product, it's a commercial product, but there's tremendous variety. Some packages are better than others. Why do I encourage SAID? It is a tremendously diverse group of packages in one. All right. Really tremendous. All right. Learning it, I would say would take a lifetime for most people. Thank you for listening.